Okay, so for this problem here, we're going to analyze the limit like we have been doing. So to do that, we're going to try to factor out the highest power in the denominator. Well, the highest power in the denominator is the square root of x squared. Okay, so in that case, that's what we're going to try and factor out of this problem. However, for this problem, the square root of x squared is not just equal to x, it's equal to negative x, because we're talking about x is going to negative infinity. So if I plug in negative 1,000 in there, if I do the square root of the square, it's going to cancel out and leave me with a negative number, okay? So that's what I'm factoring out here, okay? So I want to factor out a negative x out of the top and the bottom here. So I'm going to take the limit as x approaches negative infinity, and I'm going to factor a negative x out of the top. That's going to leave me with a negative 2 plus 2 over x. And I'm going to factor out, if you want to write it as the square root of x squared on the bottom, since that's the same thing as negative x, just to help you visualize, when I factor out a square root of x squared, I'm going to have 1 over, I'm just going to have 1 for the first one. Jumped ahead of myself. X squared divided by x squared will be 1, and then 1 over x squared for the second part, all under the square root here. Okay? So this square root of x squared is really just negative x, so we'll just rewrite this. The limit as x approaches negative infinity, negative x, negative 2 plus 2 over x, all over negative x times the square root of 1 plus 1 over x squared. So those negative x's will cancel out, and then we'll be left with the limit as x approaches negative infinity of negative 2 plus 2 over x times the square root, or divided by, square root of 1 plus 1 over x squared. Now this will go to 0, because as x becomes a huge negative number in the denominator, that fraction is going to go to 0. And same thing here, as x becomes a huge negative number, that'll square it. It'll make it positive, but it's still going to become a giant denominator. 1 over a giant denominator will go to 0. So then we'll be just left with negative 2 over the square root of 1, which is negative 2. Now, just as a reminder, that does tell us that if the limit as x approaches negative infinity, then in the left direction, we have a horizontal asymptote at y equals negative 2, because this describes what the function does as x goes to negative infinity. So to the left, we'll have a horizontal asymptote at y equals 2, negative 2. All right, let's do the same thing here for this guy. So highest power of the denominator will be the square root of x squared, so that's what we'll factor out of the top and bottom. Again, because x is going to negative infinity, this will be equal to negative x this time around, okay? Because if you cancel out the x squareds and x is going to negative infinity, you're going to get a negative number. So we'll factor out the square root of x squared on the top and bottom. So on the top, to help our brains, we'll just use negative x. So we'll factor out a negative x out of the top. 3x divided by negative x will be negative 3. And then we'll have a positive 2 over x. And then on the bottom, we can help our brains by using the square root of x squared. When I factor out that out of the bottom, I'll be left with a 2 plus 1 over x squared. When I divide both of those terms, all inside the parentheses. Oops, I didn't mean to highlight that. I meant to erase that. Okay, we'll leave the parentheses. We'll just draw our square root here, because my eraser doesn't seem to want to work. All under the square root. Okay? So then this will be equal to the limit as x approaches negative infinity. We're going to just leave the top the same. We'll rewrite this square root of x squared as a negative x that it is in the bottom, and then we have the square root of 2 plus 1 over x squared. Those negative x's will cancel, and so then we'll have the limit as x approaches negative infinity of negative 3 plus 2 over x on the top, and the square root of 2 plus 1 over x squared on the bottom. And as we take the limit as x approaches negative infinity, this fraction is going to go to 0, because that's going to become a tiny, tiny number, and same with this fraction. So then we'll be left with just negative 3 in the top and the square root of 2 in the bottom. So because we got the answer of a whole number, or a number, as x approaches negative infinity, remember this does tell us there is a horizontal asymptote in the left direction of y equals -3 over radical 2. There could be a different horizontal asymptote in the right direction. You could take the limit as x approaches infinity of that, and in order to positive infinity to analyze it, because this is not a rational function. There's a square root in it. So we could have more than one horizontal asymptote. All right, and last one here. Highest power in the denominator, again, is the square root of x squared. And again, that is going to be negative because we're going to negative infinity. So this will be negative x. We're going to factor that out of the top and bottom. So we'll take the limit as x approaches negative infinity. We'll factor out a negative squared out of the negative x out of the top. So that's going to leave us a negative x. When you do x squared divided by negative x, it'll leave you a negative x, and then a minus 2. And then the bottom, when we factor out the square root of x squared, which is the same thing as negative x, we will be left with a 3 plus 2 over x squared, all under the square root. So if I rewrite this square root of x squared as negative x, I'll have the limit as x approaches negative infinity of negative x times negative x minus 2, all over negative x times the square root of 3 plus 2 over x squared. Those negative x squareds will cancel, so we're really looking at the limit as x approaches negative infinity of negative x minus 2 over the square root of 3 plus 2 over x squared. Now on this one, this fraction down here will definitely go to 0, but this x is not going to go away. It's not going to become 0, because as x goes to negative infinity, that's going to, like if you plug in negative 5,000, that's going to be a positive 5,000. So what's going to happen? Well, the denominator will go to the square root of 3 in the bottom, right? But then we're going to have, if you plug in negative 100, you're going to get positive 100 minus 2. Plug in negative 1,000, positive 1,000 minus 2. Plug in negative 5 million, you're going to positive 5 million minus 2. Doesn't matter if you're going to subtract it, this is going to keep going to infinity. And divide that infinity by square root of 3, and nothing's going to change. It's still going to be infinity. So this limit is going to be equal to infinity. Positive infinity. Just think about plugging in giant negative numbers and what happens. It's just going to keep getting bigger and bigger. So this tells us that there is no horizontal asymptote in the right direction, or in the left direction here as we go to negative infinity, as x goes to negative infinity for this problem. It just tells us that the function goes to positive infinity. So we know the end behavior looks like that.